time to spare? Yeah. Okay, so let me hide this. And the experiment, this all it makes sure this is clear, is the activity, like tossing a coin. Okay, you're going to get different results in your activity, whatever it is. The results of the experiment are called the outcomes. Okay, so if I roll a die, one die, what are the outcomes for a die? And Radice, I asked you to move. 3, 4, I don't care. 5, 6. Okay, those are the outcomes. Well, on the green sheet, the first question has something to do with this. And it says, is rolling an even number on a cube an outcome or an event? Outcome is everything that can happen. The event is a collection of one or more outcomes is an event. Yes. So let's say one, well, I don't like to use more, but not all. Whoops. Outcomes is an event. Right. Not that it's going to be that important, but I just wanted to be clear about that because I didn't feel like I was clear. Okay, you got your green sheet yesterday, and I got some turned into me yesterday, which I could turn back for corrections. But let's do the lesson first, okay? Merdice, Ruspin? I know. You're not supposed to be sitting there. You're supposed to be sitting there. It's not an option. Do you want to sit up front? Okay, then you stay back there. No, he's going to move. Or he's going to go to the SPR. No. Okay, now, you guys, let's go back here. So the answer to one is not what you thought it was probably, but finding a theoretical probability. And by the way, some of you aren't answering questions. Some of them are yes or no questions. Okay? Now, this is what we expect to happen. But what really happens, one more. No. Out then. And I don't want to argue with you every single day, which is what's happening. So if I toss a coin, what are the chances coming up with a heads? 50. It's 50-50, or 1 out of 2. But does that really happen? Well, we've got some spinners here, so we can look at it. What you expect to happen is theoretical. What actually does happen is experimental. Okay, you can do that later. So this is the symbol for probability. Jake, we don't have any iPads out. We don't need them. No. So you don't need a calculator for anything here. Okay, so P stands for probability. And it's the number of favorable outcomes. So if I want to bet on having a heads, that's fine. How many heads on a coin?
1.
Have 1. Unless you run into somebody who's not exactly honest, and they have a double-headed coin, which happened to me back in college. He says, well, heads you're going to do this, tails you're going to do that. Well, everything was heads. So he already had it set up for me.
What was it for?
I had to make a decision on which party to go to.
Oh.
Nick, iPad, put down, please. Okay, so normally there's 1. But you can have die that are weighted. That happens. It shouldn't be. And how many outcomes if I flip a coin? 2. Okay. Now, let's find the probability that if I had a fishbowl and I put all the letters of the alphabet in there, what's the probability I would pick a vowel? How many letters in the alphabet? In the alphabet? No. Okay, well, let's list the vowels in. What are they? A, E, I, O, U.
Y. Then sometimes Y.
Yeah, sometimes Y. Let's, do you want to put Y in there or not?
Do it.
Okay. It's our game. We can do what we want. Okay, so what's the probability of getting a vowel? There are 6 chances out of how many letters in the alphabet? Jake, do you know how many letters in the alphabet? Nick? 26. We're not in Arabic, but okay. Can we reduce that?
Yes.
Yes. How would we reduce that?
2.
Divide numerator and denominator by 2 over 2. Because what number is 2 over 2? 1. And if I divide by 1 or multiply by 1, do I change the value? So I can do that. It's legal. Everything has to follow rules here. 6 divided by 2 is what? 3. And 26 divided by 2 is? 13. If I had 5 out of 26, it would be 5 out of 26. Okay. That's it. Probability, simple probability is like this. Okay. So we have a die here. What's the probability of getting a 3? So how about if we write down all the outcomes? Actually, there should be a die on this thing. This does not spin. Shall we see if I can find it? No, I gotta probably use my computer to do it. I know there's a spinning one. This is theoretical, though. So what are the outcomes? 1. Some of you don't want to write them all out, and I don't want to write them all out if I do 2 die, or a pair of dice, however you say it, because there's 36, and I don't want to write them all out. Well, there's 1 through 6 on one and 1 through 6 on the other, but there's a whole bunch of outcomes you can have. So what's the probability of getting a 3? 1 out of 6. The outcome of a 3 is 1. That's the difference. Now, I'm not going to mark it wrong if you give me probability, because I'm still trying to get the ideas here. Which ones are even? 2, 4, and 6. Those are the outcomes. There's 3 outcomes, Michael. But it's what's the probability? It's the favorable outcomes to all the outcomes, which is 6, which is 1. You know what 3 out of 6 is? Alex, you know what 3 out of 6 is? 1/2. What's the probability of getting a 6? We're not gonna do terribly difficult probabilities. 6. How many choices are there? 1 favorable outcome, which is right there, out of 6. How about the odd numbers? Why is it 1/2? Because how many odd numbers are there? We've got 1, 3, and 5, which is 3 out of 6. Yes, so we should be reduced. When we take our final exam, I want you to reduce your fractions. You may use a calculator. How about the probability of numbers divisible by 3? In other words, 3 divides into it. What's the first number I would choose? Well, 6 works. 3 goes into 6 how many times? Twice. Divide, not subtract. Okay, what's another number? There's another one. Merdice, what's another one? 3. So what's the probability of being divisible by 3? 2 out of 6, which is, reduces to 1 out of 3. Okay, what's the probability of getting a 3 and then a 5? Now, this is a little harder. We're going to multiply our probabilities. So we're going to take 1 die, and we're going to roll it. What's the probability of getting a 3 on the first roll? 1 out of 6. Okay. Then I'm going to pick it up. I'm going to roll it again. Can I get a 3 again? Yeah, I don't want that. I want a what? A 5. This is why I don't bet. What's the chances of getting 5? How many outcomes here give you a 5? It's 1 out of 6. So the probability of getting a 3 followed by a 5 is 1 chance out of how many? No, multiply. 6 times 6, 36. Not very good. And your chance of winning the lottery is 1 out of 55 million. I was at a TI meeting on last Friday, and there were like 5 of us there. There should have been more, but there were only 5. And so the guy gave out 3 Inspire apps for 2 Inspire apps for the iPad, and then the big prize was a total TI Navigator, including the software, the hardware, and I think it included 30 graphing calculators. Total about $6 grand. Okay, there were 5 people there. I did win, but I didn't win that. I won the app, which is great because it's nice to have the app. But at 1 out of 5, I go, now's my chance to win a whole navigator system. Somebody else won it. So even then, with 1 out of 5, I still didn't have a chance. 1 out of 36, I'm going to have no chance. 1 out of 55 million, why don't I just give money away? Throw it away into the air, because that's what you're doing. That's why you have to understand probability. If you have money that you have extra money, you just want to play for fun, that's one thing. But to try to play to win, to support yourself, that's not a wise thing to do, because you don't have any chance. It's almost zero. If you divide 1 by 36 in your calculator, it's really a tiny number. Okay, what if I do 2 6s? What's the probability of getting a 6 on the first roll? 1 out of 6. And then I pick it up and I roll it again. It's 1 out of 6. So yes, it's 1 out of 36. It's not very good chances. I'm not going to bet on it. It's throwing away your money. Okay, so if you do ever want to play the games in Vegas, you need to know what your probabilities of winning are. Different games have different probabilities. Okay, I think this spins. Oh yeah. Well, what's the probability of getting a tails? Those are the odds. The odds are the equal things. Probability is how many tails are there on a coin, 1, and how many chances are there? 2. Okay, so let's see if this works. Oh, I have to press stop. Okay, so we're going to do heads, tails. We didn't win, did we? That was 1 out of 2, but I still didn't win. Does that mean I'm going to get heads on the next one? Does it? Oh, there's a tails. And we could do this, and on my calculators, oh, now we're back to 50-50. You're going to give me $10 if it does? Ah. You want to do it? Can we do it really quick? Or long? Oh, there's a heads. Now let's do a long one. That's pretty good. Yeah, you could flip it, but this is easier. It doesn't make any noise. Now, on my graphing calculators, if I had them, which I don't know where they are, there are apps on there that will model this. And it'll actually show you the flipping like that. Okay, I didn't keep track of the tails and the heads, but, okay, guys, what about this probability? Now, what's the probability of getting the tails? It's 1 out of 2. Then you toss it again. What's the probability of getting heads? 1 out of 2. So what's the total chance of this? 1 out of, multiply it, 4. You can even add this one and get it right. What about the probability of 2 tails? So to get the first tails, it's 1 out of, what, 2. And then 1 out of 2. So you have 1 out of 4. Now I could toss the coin again, and we keep track of what it was doing and see if we can get that. We'll see how many times. I would have to do it hundreds of times. That's the problem with the lottery. When people say they have numbers that they pick and that they win with those, that's not possible. It just is by chance. It's just by luck. There's 55 million possibilities. That means to have hit all the possibilities in a perfect world, we'd have to have drawn that lottery 55 million times. We haven't even come close to that. Not even close. So the only way you're going to get a nice even distribution like we have right here, where I have 4 heads and 4 tails, is to probably do 100 times that 55 million. Not going to happen in my lifetime. So when you pick your numbers and it looks like there's patterns there, it looked like we had a pattern here too for a while, didn't it? But it's not true. So we haven't done it enough times to be able to say anything about it. And you'll hear people talk about that, but they don't know what they're talking about. What about 2 heads? What's the probability of the first head? 1 out of 2. Probability now of the second head is still 1 out of 2. So that's 1 out of 4. So it's pretty easy with what we're doing right now. It should be, I'm hoping. Okay, ready? Oh, we have a spinner here. Well, it spins. Okay, what's the probability of getting a green? Now we're doing probability with like areas. These are all equal. So that's 1 out of 4. Yeah, it shouldn't take us very long. What about a green and then a blue? Well, there's 1 out of 4 for the green. Multiply, you're right, get the right idea. And then blue. What are the chances of a blue? 1 out of 4. And if I need to put the smart board up with the worksheet on so you can see the colors, because you could label your colors on there. There's no way I can print them with colors. So be careful, I'm going to multiply that. It's 1 out of what? 16.
All right.
Multiply. That's good, you're just thinking. Do you think the blue and then the green is any different? No, it's the same thing. Can I just go to the answer? And see why it's the same thing, Jake? What's the probability of blue? 1 out of 4. Green is 1 out of 4. So it's still 1 out of 16. Now, if I change the number of colors so that they're not even and equal, that's different. Ooh, how about a green and then a green and then a green? Well, 1 out of 4 for the first green times 1 out of, how many for the second green? 4 times, that doesn't look like a 4. 1 out of 4. Does anybody know what 4 to the third power is? I don't know why I have this twice, but I do. Yeah, like 3 times. It's 64. Definitely would not bet on that. Hey, you ever watch The Wheel of Fortune?
Oh, I was just watching the last one.
And they land on this one little slice that, if you pick it up, is either bankrupt or you get 10,000. It's one of those two. And you can bet on it or you can just ignore it. What is your chances of winning the 10,000? 1 out of 2. It's one of the little pieces that you pick up. I don't know what you want to call those things.
Slides.
No, I don't think they rig it. But on one side it says bankrupt, and on the other side it says $10,000. You've only won $1,000. There's a lot of puzzle left to go. Are you willing to risk it for the 10,000? Probably. What if you have 8,000? Because some people get greedy. You have 8,000, and if you get the 10,000, now you're going to have $18,000. Are you willing to risk your $8,000 for that extra 10? I wouldn't, because you already just saw you have a 1 out of how many chances? It's a head-tails problem. What's the chances of getting 10,000? 1 out of 2. No, it's just one side or the other side. Jake. Yeah, they take away a lot of money in taxes. You'll end up with 25 million. But 25 million would be just fine. I wouldn't complain. That's right. Yes.
Like, for the whole thing, I was watching this girl, and she was spinning to, like, the double 20, and then she was 2 away from, like, spinning to a million, and then the guy was like, oh, well, if I got next time, you're doing this.
Oh, I just got 2 greens.
So it's kind of funny.
And,
Mostly when it's, like, chances of getting 2 away.
look at that, I just got 2 yellows in a row.
Unless you got,
Yeah, and unfortunately, you can't do this. I have these up on the Schoology as PDFs, but I can't give you that. Now, there may be websites where you can go in and do probability, and you can play with it on your iPad. I haven't investigated. I should. Okay. I just want to make sure we don't go too far. I don't know if we have to do that. No, that's green. There's today's. So we're going to do a spinner. Oh, okay, we do have to do this. This is the fair. So when that guy gave me the coin, he says, heads, you go to this party, tails, you go to the other party, and it came up heads every time, was not a fair coin, was it? Was it, Jake? Was that a fair coin when it's heads on both sides? No, not at all. Okay, fair if all possible outcomes are equally likely. So is this fair here? What are your outcomes? Green and blue. So it's fair because they're both equal area. What about this one? I've got 2 reds, 2 dark greens, and a yellow. That looks like a different color, doesn't it? Light green. Is that fair? No. Well, that's the problem in Vegas and all those other games. They don't make it fair. I did get a color. I thought it was right on the line. Okay, it's more likely to land on one in either 2. It's more likely to land on this and this than one of the other ones. Oh, let's just see. More likely to land on the green or the red? I don't think it matters. It's very random here. Well, it's not to say it's not going to come up. It's just not likely. Okay, so you understand what we mean by fair. Okay. Just want to make sure I cover everything for today. And I think pretty much we can do this. Okay. Oh, we're not doing the probability carnival. We don't have time, unfortunately.
No.
Yeah, that's beyond us. Okay, I think that will do us. And then you should get the green worksheet into me.